Thank you for joining CML InfoTech. We are talking about the TCP from the ISA reference model. My name is Mohammed. So today from CCNA, day 3, part 2. Any doubt? Okay. So we discussed about the TCP. And I was stated earlier that there is a header, and every layer there is a header. Application layer header, presentation header, session layer header. So the header in the sense, any specific layer, if I'm adding that layer protocol will be considered as a header. Let's say in transport layer, I'm adding TCP, then it is called TCP header. When you open TCP, you can see many content in that protocol. That is all together, we call it as a header. So here, if I'm talking about the TCP header, we can see few information in this. Like for example, source port number and the destination port number. What does that mean? I said earlier, the application layer protocols are added into TCP for moving further from the transport layer onwards. So let's say if I am sending some data over the HTTP, when the HTTP is adding into TCP, then the source port number is 80, which is HTTP. And the destination port number, the one who received the port number. So every communication, by the way, it needs the source and it needs the destination. Two informations. Who sending, to whom they are sending. So source port number and the destination port number. So 2 bytes means 1 byte is equal to 8 bits. So we will have this chapter today or tomorrow, upcoming sessions. So the 65,535 ports, which are 16 bits, is equivalent to 2 bytes, the source port number. And the sequence number, the sender who adding a number on every segment to address the total numbers. If I'm sending you a data which contains the 10 pieces, the receiver must need to know that, yes, the receiver has received 10 pieces. അയക്കുന്ന ഒരാള് എത്ര ഡാറ്റ അയച്ചു എന്നുള്ളത് റിസീവറിന് അറിയാൻ വേണ്ടി അയക്കുന്ന സിസ്റ്റം അതിന് ഈക്വലന്റ് സെഗ്മെന്റ് ഓരോ നമ്പർ ഇടും. That's called segment. That's called sequence number. Acknowledgement number, the one the receiver, after receive, the receiver will send back to the sender that I received this much as an acknowledgement. Then you can see a few additional points here. Window size checksum, we'll discuss that later. So the same in a different way. Like the header length is the total length of the header of the data. And you can see urgent, URG, urgent, ACK, acknowledged, PSH, push, RST, reset, SYN, synchronization, sync, FIN, finish. Let's say I want to see is there any acknowledgement. Instead of opening the acknowledgement number field, if the ACK is on, then I can see that I need to check in the acknowledgement. If ACK is off, which means 0, then I do not need to check in the acknowledgement. If urgent is on, which means I need to send the data very urgently. Something like this, but this is called TCP. And you just need to compare with the UDP. Let's, for example, this is UDP. If you compare UDP and TCP, you can see in the UDP source port and destination port. And the TCP source port and destination port, both are there. And the length and checksum. What is missing here? If you look into the sequence number, acknowledgement, or urgent acknowledge push, this field are missing in the UDP. So when you send something over the UDP, you cannot judge that can be reached 100% to the destination. There could be a loss. So will we address this in the, how can we address this in the reality? Have you heard about Wireshark software? So I just installed. I can give you the file you to install in your system for testing. I install and just turn it on. So this is called Wireshark Network Analyzer. There was another software before called It Real, and this is the one of the latest one. Here you can see the n number of interface that you can filter. Or if you can go to the capture, then you can put the option. There you can see which interface you need to capture it. Let's say, for example, I'm going to use a Wi-Fi, which I connected over the Wi-Fi network. So in the Wi-Fi, you can see the interface, which is my IP address of the system. I'm just connected and I put manage interface. So here you can see many interfaces are available. So let's say here Wi-Fi, you can see the data transaction is higher. I just double click. The moment I double click, you can see many transactions in this. So here you can see source IP, and here you can see destination. And you can see here UDP, then the maybe TCP. Yes, you can see TCP. There is a kind of transaction. Let me filter one. Here I can give a I can filter the IP. Let's say, for example, I'm going to filter TCP. Now you can see many of the services from TCP. Let's say if I just open one transaction in TCP, okay? And here you will get the summary. And on the bottom line, you can get the details. As an example, you can see only here TCP, the last one. Let's say I'm opening the TCP. There you can see, I just wanted to cross-check the slide. If you look into the slide, you can see source port, destination port, sequence number, and acknowledgement. Just remember 4 points: source port, destination port, sequence number, and acknowledgement. This will be compared in the reality. Just I filtered my Wi-Fi network connection, which is connected to the internet. Here, if you look into this transaction, you can see source port number 443, which is HTTPS. And the destination port is random port. And here you can see sequence number 1012. And you can see there is an acknowledgement for respective to the TCP. And you can see this flag. This flag, if you remember, this flag is referred into this urgent ACK push reset. This is called the flags. We have 1, 2, 3, 4, 5, 6. Or you can see here control flags, which is 9 bits. So which is referred here urgent ACK push. We are comparing this and including reserved in the reality. If you look into this, you can see some of them are called reserved. And you can see here urgent. There is nothing because 0. And there is an acknowledgement here always referred with a 0 or 1. 0 or 1. 0 means nothing. Here you can see acknowledgement is 1 which is set. What does that mean? You can see on the top there is an acknowledgement is filled with some numbers, which means the acknowledgement is active. Then finish, sync, reset, push, this all 0. There is no information regards to this. Then if you come down, you can also see there is no additional information regards with the application layer. What does it mean that? Can you refer any application layer protocol? Example, HTTP. Here you can see one HTTP protocol, which is application layer. If I am taking that, you can see after the transport layer, which is TCP, then again you can see HTTP. If I expand this, you can see here the destination port number is 80, which is equivalent to TCP. And again, there is an acknowledgement. Also, you can see TCP, HTTP here. There are some information. I think this is regards with the Microsoft website, which is Keep Alive, and some Microsoft site is shown. Okay, so this is regards with the HTTP. Or if I can do something, other application layer protocol, or let's say simply if you filter, you can see here UDP, TCP, TLS. What is TLS? Transport layer security. If you look into that, you can see the transport layer security, which is some information about application layer data. Okay, just we are filtering about application layer and the higher layer and the TCP, and we also have layer 3, which is called IP, and we also have a layer 2, which is called MAC address. If you open layer 3, you can see details about your IP address, source IP and destination IP, which is called layer 3. If you open layer 2, which is Ethernet, you can see source MAC and a destination MAC. So generally, we will be referred as layer 2, layer 3, and layer 4. Every layer must have from and to. So if you talk about layer 2, we can see source MAC, destination MAC. If you open layer 3, which is IP, you can see source IP, destination. Source IP is my system IP, which is 1.104, and destination somewhere in the internet. Then if you look into the network layer, the transport layer, even you can see the source port and destination port. So what I meant that if you look into layer 4, which is called port address, you can see source port, and destination port. Then the layer 3, which is IP, source IP, destination IP. Then the layer 2, which is MAC address. You can see source MAC and destination MAC. What do you mean by that? Source MAC and destination MAC. Source means from, destination means to, which means when somebody sends some data from their computer to another computer, it required an information about from and to. What all information that you need, which IP to which IP, which MAC to which MAC, which port to which port, along with the data. So this is we call as a physical or the hardware seed. So if you referred layer 7, layer 6, layer 5, this is all we call as a data. Okay, then we call layer 4, which is transport layer. As an example, TCP, which has port numbers. Then we will come to the layer 3, which is network layer. We will come to IP, which must need source IP and destination. Then the layer 2, which is data link layer, must need MAC address, source and destination. So any transaction which you are filtering from here, either it could be TCP or it could be UDP, anything, you need a detail about. If you look from here, you can simply say that my source IP 104, my destination IP 37, my protocol being used UDP. The detail within that, you need to just click, will come to the detail underneath. So here you can see that the layer 2, which from the source MAC and the destination MAC. And from the layer 2 itself, you will come to know what kind of IP that you are using in upper layer, which is layer 3. Let's say here IPv4. Why it's defined IPv4 in detail? Because there is an IP called IPv6 as well. If you are using IPv6, it will be referred as IPv6. So you came to know from layer 2 that you are using IPv4. Then I'm going to layer 2, sorry, the layer 3. The layer 3 says that what kind of IP it is. Let's say version 4. Then it will also tell us about what is the source IP and what is the destination IP and what protocol it is used in the upper layer. It's UDP. Then you will be looking to the UDP. It says that what is the port number it is used. And because of UDP, you cannot see acknowledgement. You cannot see sequence number because UDP doesn't have those info. Then you can see the data. What is the data? Some sort of data here. So instead, if I am searching, let's say TCP, you can see sequence number and the acknowledgement, which is sequence number and acknowledgement is 0. So it's not pure data. Okay, so coming back to the diagram, the presentation, we can see that the TCP and the UDP and the real functions about it. Any question? Do you have any doubt? TCP. When you start preparing the lab, when you do the lab, you need to go through via Wireshark to address that the learned theory are matching with my real concept, and that will make you help when you do troubleshooting the network. Now we're going to talk about network layer. What is the meaning of the network layer? Starting from network layer, their hardware is also being involved. Some questions been raised earlier that what is layer 3 switch, what is layer 2 switch, there's a manageables, all comes to the picture starting from here, from the network layer. So the major role of the network layer to identify the source and the destination or the best path towards to the destination. We'll go to this scenario. Yeah, the network layer. In the network layer, will be address the best path. What is the shortest route to reach my destination? There are two sets of protocol in the network layer. One is we call it as a router, one we call it as a routing protocol. Here the name comes as a routing protocol. The routed protocol, which are IPv4 and IPv6, along with the IPX and AppleTalk. And we majorly learning about V4 and V6. And the routing protocol to communicate a different network either by using one of these protocols like RIP, EIGRP, OSPF, on-demand routing, ODR, ISIS, or the BGP. We will be covering majority from this. And the PDU, under the network layer, we call it as a packet. So for example, if you look into your source from the computer to the destination, you will be having multiple paths towards to the destination. So which path is best in this? All are best, or any one of the best? Or there's a best and the backup, then the backup will go in such a way that's all being addressed through the network layer. Of course, we will have a practical session to address this. Now, coming to the point, the network layer product. There are major two hardware equipments is being involved in the network layer. Either we call it as a router or we call it as a layer 3 switch. So what is the meaning of these two, router and a layer 3 switch? So we'll come to that point. So let's say we need to keep in detail on this. Let's say we have computer. We take an example as a computer. I have 3 computers to make them into a network. And this whole system will have NIC, network interface card. If I have a 2 computer, I can pull the cable like this to make them a network. Instead, if I have more computers or more network devices, I need a central product. We'll try to give an example as a switch. I'll give you an idea what's the difference between repeater, hub, bridge, and switch. We're just focusing now as a switch. I have a switch here, and switch will have a port. And this port will have a number 1, 2, 3, 4, 5, 6, let's say 7, and 8. 8-port switch. I'm going to connect the first port to the second port to the third port. The way I can connect 8 devices into the switch. When I connect a system into a switch, the system also need an IP address. As an example, I'm going to give you IP address 1, IP address 2, IP address 3. If my whole computer are in the same network, and those same networks are capable to communicate by using this switch, then I'm going to say this layer 2 switch. Or if my all 3 computers are able to communicate each other, sending data one system to another system by having this switch, this functions I'm going to call as switching. What we call switching. So what is switching? Sending data from one network to the same network. It could be system, it could be a camera, it could be access point, anything. If I'm sending the data from one network to the same network, I'm going to call it as a switching. Okay. Then the switching functionality is done by switch. The switching functionality is done by switch. Okay. In order to communicate system under the switch, this need MAC address. Okay. Now, I'll come in this way. I have a layer 2. I have a layer 3, which is data link layer, which is network layer. Let me say MAC address is a layer 2 address. Do not ask why, because this has been already defined. MAC address is a layer 2 address. All the device who works based on the MAC address, or the device who takes decision based on the MAC address, will call it as a layer 2 device. Device who takes decision based on MAC, called layer 2 device. Example, bridge or switch. What I mean by the decision? Let's say I connected 3 computers in the switch. In order to work these 3 computers, they are connected to the switch. So switch need to know who they are. Like, you know who am I by using my name Ali, and I know who you are by using your name. The same way, to send the data from one computer to another computer, the computer will send to the switch, and switch will send to another computer by knowing their MAC address. So the switch will work based on the MAC address. So now, layer 2 address, MAC. Layer 2 device, switch. Why switch is a layer 2 device? Because switch is working based on MAC address. And switch perform, what the switch will do? What the switch will do? Switching. What is switching? Sending data from one network to network. One network to the same network. Because of switch is a layer 2, and the switch is performing switching, the layer 2 function called switching. Layer 2 address MAC address, layer 2 device switch, because MAC address works based on switching. Then the switch will work based on the layer 2, and the layer 2 switch function is called switching. So I'll give you a summary. And before, do you know what is switch? I'll give you an example. Can you see my screen? Hope you can see my screen. Here you can see Catalyst 2960, 24 port. This is called switch. And this switch will have port number. So to communicate computers or any network device, I need a switch like this, and will connect the UTP cable, copper cable, from the computer to the switch. So this is the switch, and this switch will perform switching. And this switch from the Cisco, and if you look into this switch, you can see this is from the extreme networks, also have the port number to connect the system. So when I connect my computers or camera or access point, any network device, into this switch, the switch will help the connected device to communicate each other. and that functionality will be referred as a switching. And this switch in the OSI reference model will be placed in the layer 2 because of the function, because of the switching. Okay. Now we're coming back to the point. Now we can say IP address. IP address is a layer 3 address. Any device could take a decision based on IP is called layer 3 device. Example, router. This is the symbol of the router. Router is a layer 3 device. What the router will do? Example, I have one switch which have 3 computers. And this is called, what we call this? Switching, sending data from one computer to another computer. And I have another network, another switch. The switch from a Cisco, Aruba, HP, Extreme, Ava, it could be anything. I have a few computers, which is another switching, or we can call it as a network. This is my first network, and this is my second network, or we can call switching. Now, I wanted to make them communication from here to here. They are different networks. So I need, what do I need? Inter network. Or I could say state and state, interstate, something, different network. I need to communicate from one network to another network. So I need a connection from this network to the router and from the router to another network. Hope you understood. So what the router will do? Receiving a data from one network and sending data to another network. Or the router will help us to perform between one network to another network. What the switch will do? Let's say I'm writing 2 computers connecting to one switch. What the switch will do? Sending data from one network to the system at the same network. Sending data on the same network. The router will do sending the data from different network. Sending data from one network to another network. This function called routing. So we have switching, we have routing. Sending data from same network to the same network, switching, and one same network to a different network called routing. That's called router. Or switching performed by switch, also called layer 2 switch, which is look like this, a simple. Routing can perform by router, which is referred as this. Or I can do routing with layer 3 switch, which will be look like this. So let's say here, if you look, switch symbol, this is called layer 3 switch, who can perform different network communication. And this layer 3 switch in the reality we call as routing. We call as multi-layer switch or routing. So the routing can perform either via router or via layer 3 switch. So how do you know by looking in the switch whether it is a layer 2 or whether it is a layer 3? What is an easy way to address? Either in the earlier stage, couple of years back, I would say, or I was giving an idea that from Cisco perspective, any number lesser than 3000 called layer 2 switch. Let's, for example, 2950 switch or 2050. This all called layer 2 switch. And the layer 3 above 3000. This is lesser than 3000. Higher than 3000 called layer 3 switch. Example 3750, 3550, or 3560, or 4000 until 12,000 series of switch. Now it's been changed. Now we need to look into the data sheet to see whether it is a layer 2 or layer 3. As an example, in Cisco, if I would say 292950, it's a layer 2. Or if I would say 9200, it is layer 2. And 3750, 4750, or anything 4xxx, or anything 5xxx until 12,000xxx, we call it as layer 3 switch, who have the capability to perform routing. Now, the switch who can perform routing, we will be referred as core switch. The switch who can perform layer 2 or switching, we call it as access switch. So what is the difference? The routable switch, the routing switch, or if in the network, if we do routing, we call it as layer 3 switch, or the switch who can perform switching, we call it as access switch. In something, we will be change it the later, the name, I will let you know. So let's say, any doubt in this? And there is a 2 switch called manageable and unmanageable switch. Unmanageable switch, which is a dummy switch, that switch is always a single network. If you bought, example, if you bought a dealing switch worth like a 200, 300, 400, I don't know the exact price, something, the common switch which we purchased from the local shop, like 8-port switch, and you connect all your system into that switch. You cannot manage that switch. You need to simply connect, work on that. If you wanted to manage, then you need to go for manageable switches, which again, you will be available from a different vendors, including T-Link. So what is the meaning of manageable and unmanageable switch? We'll let you know this one. Do you have any doubts? So thank you for joining with us from CML InfoTech. We discussed about the Wireshark layer 4, layer 3, and the switches from layer 2 and layer 3. Thank you. Have a good day.